Hi everybody, last video for this entire module. I hope you're excited. We are going to look at a slightly more complicated modeling problem. And it's only more complicated, honestly, in the fact that you are using percentages and having to deal with those percentages. Let's make that a little more obvious. Here we go. So here is our equation, or here is our scenario. Our job is to create let statements and then solve the system to figure out the answer. There are two types of milk. One has 1% butterfat and another with 3.5% butterfat. They are mixed. How many liters of each of these milks need to be mixed together to produce 10 liters of 2% butterfat milk? Okay, so first of all, we need to create our let statement. So we need to let x be something and we need to let y be something. If we look at these two things, what are the variables here? Like, what are the things that are going to change? And that is the number of liters of 1% versus the number of liters of 3.5% milks. So x, we'll let x be 1% milk. And we will let y be the 3.5% milk. After we do that, we can start creating our equations. One equation, we are going to just simply look at the liters of milk that we are dealing with. So we have x liters of 1% milk, so however many liters of 1% we need, plus however many liters of 3.5%. All of that needs to equal 10 liters. Now we can look at the percentages of butterfat and we can try to figure out how to make just 2% butterfat milk. So if we look at that, we're looking at 0.01x, so 1% is 0.01, written out as a decimal. 3.5% is 0.035y, and that is going to equal not just 0.02, but if we notice here, we have the x and the y here, which mean the liters of milk for each of these. So that means I need the number of liters of 1% milk plus the number of liters of 3.5% milk equaling the 10 total liters of 2% milk we are going to have. Now we are going to take all of this and actually solve for one of those variables. Let's do substitution because that seems easy enough. So I'm going to subtract x from both sides. So we get y is equal to 10 minus x. And from there I can put this equation in for this y variable right here. 0.01x plus 0.035 times 10 minus x is equal to 0.02 times 10 is 0.2. We're just moving that decimal place over and we multiply by 10. Right? All right, so now we can simplify this. 0.01x plus 10 times, I'm going to distribute this in, 0.35 minus 0.035, x is equal to 0.2. Let's subtract 0.35. And we can also combine these two terms here, so we get negative 0.025x is equal to negative 0.15, and then we can divide those two values. So 0.15 divided by 0.025 is 6. X is equal to 6, and this needs to be in context. X equals 6 liters of 1% milk. Okay, so now I'm going to use this value here and put it back into this original equation here because it's the simpler of the two. And so I get 6 plus y is equal to 10. That means y has to equal 4. And 4 liters of 3.5% milk. Technically, I am done because I found what my x and y equal. However, they're so far apart on the page that I would like to have them closer together. So we can say 6 liters and y is equal to 4 liters of 1% of 3.5%. And call that super good. And then I'm finished. Kind of a cool problem, and I really like the decimals in there, and I really like the multiplication by 10, so the factor, or the multiple of 10 that goes in there that causes us to move the decimal point and that sort of thing is kind of fun and exciting, and I like it, and it looks like my mirror is a little smudged. Either way, it's causing like a little fuzzy spot right there. I apologize. All right, so have at the must-do practice problems, then attempt the exit pass, and then ask questions if you have them. Modeling systems of equations is not always easy, so I do expect questions. Please ask them. Thank you so much for watching, and I will talk to you later. Bye.